working our contract. So first we'll give the license spdx license identifier unlicensed. Now we give the compiler version Solidity 0.8.9. Now simply import the packages which we need in this project. So here we are using OpenZipling counter. So we want to keep the track of every candidate and every voters. For that we are going to use this counter from OpenZipling, and we have also using Hardhat console, so we can see the logs in our console. Let's create a contract and call it create. Inside that we're going to use counter from counter and counter. So this is how we have to use the plugins which we use in our smart contract. So first we have to use the keyword using, then we have to define the contract counter and what function we want to use inside that contract. So make sure you give the same name. Come down, we'll use this counter, counters.counter, and I keep it public so we can call it outside the contract, and I call it voter ID. This will also be a counter public for candidate ID. Now let's come down, let's take an address, and this will be public, and we're going to create an address for the voter organizer, the one who will deploy this contract. So voting organizer. Now let's start working on the candidate. We'll define the struct and we can call it candidate. First we'll take the unt for the ID, candidate ID. Now we'll take a string, and here we're going to save the name. So the reason why I'm taking age as a string, you can take it as a number, but I'm going with this way. Okay, you can take it as a number, no problem in that. We'll take name, we'll take the image, because we also upload the image from IPFS and we're also going to add the image in our smart contract. Okay, now we'll take the unt, and inside that we take the voter count, so how many votes the voter is getting, and now we have to take the address of the candidate, and now the last one is going to be IPFS. So this IPFS will contain all the information about this single candidate. So what we will do, we'll upload the entire data of this candidate to the IPFS, and from there we're going to fetch and add as a URL. So if anybody wants to look at the details about this candidate, they can simply visit the link, and there they will find all the details like candidate ID, age, name, image, voter count, address. So that's the idea I'm just going with. So we are done with the candidate. Now let's come down, and we have also do the event. So create event, because event is a very cheaper way to save data on the blockchain. So I'm just creating this event. So simply copy this and paste here. Let's assign an index, and let's select this part and select all these and remove with this comma, and the last one we don't have it. Okay, so that's our event. Let's come down, let's take an address. It's gonna be an array, and candidate address. So all the address of the candidate we're going to store inside this address. We'll do the mapping, so I'll call it address and candidate public, and this will call candidates. Let me give this comment end of candidate data. Okay, now let's start with the voter details, voter data. Let's come down, we'll take address, and it will be public voters. Now one more address, public, and it would be voters address, and we have to do the mapping. So I'm going with the address, so voter and public, and this will call voters. Now let's create the struct for the voters, so let's call it voter. So first we'll take the unt for the ID, voter / voter ID, string, voter name, again string. We'll take voter image, We'll take address, call voter dash address, address. Now we'll take a unt, it will call voter allowed. So we want to keep the track of the voter, that whether the voter is given the vote or not, or whether he or she is authorized to give the vote. So that's why I have taken this allow variable. You will see everything when we plug everything together. Now boolean, and this for is voter voted. So whether the voter is already voted or not, that will keep the track of this boolean. Okay, and we'll take another unt, this will call voter vote, and the last one is going to be string, it's called voter IPFS, which contain all the information about the voter. So we are done with the voter struct. Let's come down, let's create the event for the voter created, and simply we're going to paste it, and we have to assign an index, and simply replace all this with comma. So this is the voter and event and struct. Let's come down, let's give this comment end of voter data. Now we have to create the constructor. So what we have to do is we have to set the inside the constructor, we're going to set the organizer. So voting organizer is the message.sender who will deploy the smart contract. So simply come down, this is our construct. We'll take a function, this will call set candidate. Now let's create the function for the set candidate. Inside that we need address, we'll call it address. We'll take string and memory, it will dash age. And the reason why I'm taking the variable name like this dash age, because I don't want to create any name conflict, because the same name we have in our struct, so it's better to take this dash notation in your data. Okay, again memory, and this will call name, will have a string, and this will call memory, it's an image, string memory, it's a IPFS. Just provide this bracket. Now let's come this public. So this is the function, all the inputs we're going to receive in this set candidate. So first required, so we have to do some conditions. So voting organizer is the one who going to create this candidate. Okay, so that's the very first check we have to do. If someone else call this function, we have to say only organizer can create the candidate. So that's the very first check. So let's come here, and I think I misspelled, and simply paste here. So this is the very first check we have to make in set candidate. Let's come down and let's take the ID, this one, and now we're going to use the increment function. So every time we'll create a user, this number will keep updating. Simply click on this and you will come to the plugin. So here is the function, complete function of the package we are using in our smart contract. As you can see, it has three functions. So the very first function we have is current, second one is increment, where we are increasing the number, and the third one we have is decrement. Okay, so this is the counter package, this counter package we are using. Okay, this one plus, let's close this one. Now let's store into a variable called ID. I'll call it ID number, and where we're going to pass this candidate ID current. This current function will give the current ID number which we're going to assign. So let's call it candidate storage, and let's call it candidate with a small c, candidates, and we will pass the address. Okay, that's the address we receive from the user, that's we're going to pass it here, and this is how we are mapping. Come down, let's take a candidate dot age, and we're receiving the age from the user. As you can see here, we have defined all the properties of the candidates, and that's what we are providing here. Let me close this one. As you can see, this is the index, this is the age. So that's all the value we're going to assign one by one. So let's remove this to name. This will call name, replicated, this will call candidate ID, and here we have to pass the ID number. Let's replicate it. This will call image, and this one is also image. Replicate it. This one is voter count. Initially it will have 0, and let's assign an address. Let's call it address. This one is IPFS. So here we got all the data and we have updated our struct. Let's come down, and now we'll take that ID candidate address, and I'm going to push all the addresses of every single candidate in this candidate address. Okay, so here we have the array and that we are pushing. Let's come down. Now we have to emit the event, so we have to pass all the properties. So here we have the properties. Make sure whatever order you have defined in your event, the same order you have to assign, follow here, otherwise it will throw an error. So order is matter when it's come to emit. So this is going to be a number, this one is the age, name, image, and this one is a candidate vote, this one is a IPFS. I think everything's look good, so I'm maintaining so make sure follow the same order. So we have followed the order. So we are done with that set candidate function. So this is the data we are taking, first check, then we are incrementing, then simply creating a copy. And the reason why I have taken the storage variable, because we are changing the state variable of our smart contract. Okay, so this function will change the state variable of our smart contract. That's why I have used the keyword storage. And when you don't change the state variable, in such cases we use memory keyword, because memory keywords allow us to create a copy of our smart contract that can be only execute during the function. So once the function get over, that data will not update it. Okay, so that's what you have to keep in mind, that what is the difference between storage and memory. So we are creating the copy, we are updating that, and we are emitting. So we are done with this. Let's close this one. Now let's come down. Let's create another function for get candidate public, and we have to use view and return, and in that we have to return address, all the address, and it's gonna be a memory. And I have used the memory keywords because because address is my state variable and I want to create a copy of it in this function, because I'm not updating my state variables. That's why I've used the view keyword. Will return, and it will call it candidate address. So it will give me all the address which we have created as a candidate. Okay, now we'll create another function, and this will call candidate length. So it will give me the length of the candidate we have in this contest. Return, and it's gonna be a number, so that's why we have to take unt return, and it will call candidate address dot length. This function will give me the length of the candidate. Now let's come down, let's create another function, and this will call get candidate data. So this function will allow us to fetch every single data about a single candidate. So we have to pass address, and it will be a public view because we are checking the state variable. Now we have to return it and all the values. So let's remove this one. Okay, bracket, and inside this we have to define all the properties, all the value of the candidate which we want to retrieve from this function. Okay, so we will pass the address in this functions, and on the base of that we're going to extract all the data. So first thing, we need a string, and it's a memory. Then second one is also a string, memory. Third one is unt string and memory, and it's again unt string memory address. So all the data we are trying to extract from about this user. So we are trying to extract all the data about this candidate, and that's what we have passed here. So here you can see these are the details we want to take. Let's give the bracket, we'll return it, we'll take the candidate. So this is the candidate in which we have the data. We have to pass the address, and we have to pass the property which we want to take. So name simply. For this is for name, this one is for candidate ID, this one is for image, this one is for voter count, and this one is for IPFS, and this one is for address. So here we are taking all the data of this candidate. So let's assign this comma. So here how it's look. So but we are getting this error. Okay, so let's try to fix it. So it's saying okay, still we are getting error. Let's move ahead and work on the voter section. We'll see what's the problem. So okay, this is good, everything's working fine. Now we don't have the error. Let's call it function voter right, and this function will allow us to create voters who can actually give vote in this voting context. Okay, so the parameter we're going to pass is the address. We'll pass the string memory, it's gonna be a name. Then we have to pass another string, it's gonna be image. Then we have to pass another string, it's gonna be call IPFS. Let's assign a space, and it's gonna be a public, so we can call outside of this contract. And we have to do some check. Okay, so the condition is going to be for this voting context that only a contract owner can create the voters. Okay, so that's the check we have to do. So voting organizer equal to message.sender. So whoever will call this function, it has to be the organizer. If it's not the organizer, then we have to display this message, only organizer can create voter. Okay, so let's come down and let's create a voter ID, because we want to keep that increment, and we're going to use the increment function. So let's come here, we are still getting this error. Let's close all this tab, and this one is the ID which we are incrementing whenever we create the voter. Now let's take a unt, it will call ID number, and you guys know the drill. The same thing we have to follow here as well. So voter ID current, and still we are getting the error in this function get candidate functions. So what's the problem? Let's come here, let's open this. We have the order perfect. Okay, here we have this comma, just remove that, and just remove the comma from the address. Okay, this is how it should be. And now I think we don't have the error. As you can see, the error is gone. So remove the two commas, one from the last address and one from the bracket. Now let's close this one, let's come down. Now we'll take the copy, it's gonna voter storage voter. So voters, inside that we'll pass the address, and now we have to update the fields. So first we have to do another check before we create the voter. So the check would be voter allowed, it has to be 0 equal to 0. Okay, and that 0 means that the user is not already registered on the contest. So if account is registered, so the entire funda of doing this check, that whenever we register a voter, we'll assign a allowed value to 1, and that's one we're going to deduct once the candidate give the vote. So when we create a new voter, they will have as a allow property to 1. So that's how we are doing the check. Okay, so let's format this. Now take voter dot allow is equal to 1, because initially the first voter would have 0, and we have to update that to 1 so we can make that check. Okay, we'll have to simply come down and name this to name, and this will be name, this will be image, and this one is also image, address, ID number, voter ID, voter, and this one is initially it would be 1000 for being the safe side. Okay, I just gave this random number, and the last one is going to be false, and this one is voted, and this one is going to be a IPFS and IPFS. So here we are updating all the data about the voters and assigning all the values. Let's come down, and now we have to push the address, voter address dot address. So here we have the array, and that we are having all the address of the voters. So in that, come down, and now we have to emit that event. So we'll call voter create, and make sure you have to follow the same order as you have defined in your emit event. Here we're going to be number, this would be name, this would be image, and this would be address. And copy this one. I think this one, I think something wrong. Let's come back. So number, age, image, and this one is allowed, and this one is address. And now we have to come, simply copy this one. We have to put all this together. Simply copy this, paste. Now copy this one, paste. Now copy the IPFS only, and here we have all the data of that event. So far everything's good. We have successfully created our voter right function. So here is the check, here is all the data and the event. Let's close this function. Let's come down. Now let's create the function for vote. For that, we're going to take the address of the candidate, and we're going to take the ID of the candidate. We're going to take these two data to make the vote happen. Okay, voter ID, candidate vote ID. It's gonna be external function, so anybody can call outside this contract. It's gonna be a voter storage, and again voter, and we have to follow the same thing. In that, we're going to pass the message.sender. So whoever will call this function, we're going to take that account, and we're going to compare and create a copy of it. Okay, let's come down. We have to do one check. So voter dot voter, so you have already voted. So here what we are checking, that initially we are assigning voter voted to false, but here we are going to opposite. So if it's true, that means the voter is already voted, but if it's not true, then they can give the vote. So that's the very first check. Then one more check we have to do is voter dot voted allow. It has to be not equal to 0. Okay, and here we have to type you have no right to vote. So if an account has a 0 allowed, that means he's not registered or he has already given the vote. We'll take the voter dot voter slash voted to true. Okay, we have to turn it to true, and now we have to take that voter dot vote, that's going to be equal to candidate vote ID. Okay, so this will allow us to keep the track that which voter gave vote to which candidate. Okay, so that's why we're going to make this track. We'll take another voted voter dot push, and in that we're going to pass the address. So here we are taking the track of all the account which has already given the vote. Okay, in a form of array. So here, come up, here we have that address. Now we'll take that candidate address, and then we're going to pass the candidate address, and it's gonna call vote count, and we want to increase the candidate voter count. So voter dot voter allowed. So voter number is going to be added to the candidate count. That's the simple logic. So with this, we are done with this entire voter function. First we are taking the candidate address, then we are taking the ID, and this is the first. So here we are taking a copy of our voter struct, and here we are checking the condition, then we are updating the data and making the vote happen. Okay, so everything is ready, look good. Close this one, come down, let's create another function, and this will call get voter length public. It's gonna be a view return, and we are returning numbers, so it's gonna be a uint 256. now we have to return the voter address dot length, that will give us the total number of voters. Come down, now let's create another function. This will call voter data. This will give us the detail about all the voters, so we'll pass the address. It's gonna be a public view, and we have to return, so simply give us this bracket, and we have to define all the things which we want to return. So first is going to be a uint, then we have a string, then we have another string with memory address, string memory, and it's gonna be a uint boolean, bool. So these are the things we want to return from these functions, and now we have to return the data. So voter, we have to pass the address. So first one is a voter, let's say voter ID we have to take. Now second one is going to be name, third one is going to be image, fourth one is going to be address, fifth one is going to be IPFS, and sixth one is going to be allowed, and seventh one is going to be voted. So here we are getting all the data of this particular voter. Okay, everything's look good. With this function we can able to extract all the data of the single voter on the base of the address. Let's come down, let's create another function, and let's call it vote get voted voter list. Okay, so all those who already given the vote, we have to keep the track of that and get the data. So we'll pass the address, array memory is gonna be, then we have to return simply. So voted voter. Now one more function we have to write, it will call get voter list, and gonna be a public view return. We have to pass the address in the form of array, we have to, and simply return that voter address. So this will give us the list of all the voter, and the upper one will give us the list of those who have voted. Okay, so we're done with this function. We are done with this voter data, voter length, this is the voted, and let's close this one, and this is voter struct. So everything is working fine. Let's format things. Okay, so with this we are done with the smart contract of our voting context. We have to write two more functions, one for the winner to find that how many vote he or she has got. So we have to write that one functions, but that will do later. Once we'll build the UI and we do this all voting, then we're going to write that. Okay, so here we have all that smart contract for the winner. Everything's looking good, we are not missing anything. If we find that we have missed anything, we'll definitely come back and add that functionality in the smart contract. Okay,